In this quick math video, we will look at ways to find if a number is a perfect square or not based on properties of perfect squares. Now, what is a perfect square? We know that it is nothing but the square of any whole number. And so a number divided by itself is its square and becomes its perfect square. Now here we have the perfect squares of the first 20 natural numbers starting from 1 all the way to 20. And what do we see? We are trying to find out if there is some sort of a pattern here. Now if you look at the last digit of each of these squares, you can find a pattern here. What you see is the square of 1 is 1, of course, 2 is 4, 3 is 9, 4 square is 16, and so on and so forth up to 20. 20 square is 400. Now from the sample set of the squares of the first 20 natural numbers, we see that the last digit of each of these squares is either one of 0, 1, 4, 5, 6, or 9. Immediately we know that if a perfect square or if a number ends in 2, 3, 7, or 8, that is not a perfect square. And this pattern you will see in all of the perfect squares known. And so this is a quick and easy way to determine if, by looking at a long number, if it ends in 2, 3, 7, or 8, you can immediately say, yeah, that's not a perfect square because it ends in 2 or it ends in 3 or 7 or 8. Because we know the property of a perfect square is that there's no perfect square that ends in 2, 3, 7, or 8. Alright? Then let's look at some more properties. What else do we see? Or what else can we find out? So when we add each of the digits of a square, it adds up to what? It adds up to 1 or 4 or 7 or 9. As you see from the table here, each of these perfect squares, the sum of the digits equals either 4 or 7 or 9 or 1. So there's another property. If the sum of the digits of a square of a number do not end in 1, 4, 7, or 9, then that number is not a perfect square. Conversely, if the sum of the digits of a number end in 1 or equate to either 1, 4, 7, or 9, that number may be a perfect square. Doesn't have to be, but could be. So that's another method of elimination. Okay? Another property here is if you are looking at squares of numbers or squares that end in 6, then the tens digit here, like for instance you have the square of 4, which is 16, and it ends in 6, the tens digit is either 1, 3, 5, 7, or 9, so it has to be an odd number. You see it here as well. Square of 14 is 196, it ends in 6, the tens digit is 9, which is an odd number. Same for 16 squares, 256, the tens digit is 5, which is an odd number. Same goes for 6 squares, 36, the tens digit is 3, which is an odd number. That's another property of a perfect square. Alright, and now we are trying to find out what is the underlying pattern for a perfect square. So let's take, for instance, 5 square. Alright, 5 square can also be written as what? 4 plus 1 square, right? And then we know a plus b square is nothing but a square plus 2ab plus b square. So applying that formula, we get 5 square is 4 square plus 2 times 4 plus 1. So in general, the formula becomes n plus 1 square is nothing but n square plus 2n plus 1. So 2 square is nothing but 1 square plus 3. 3 square is 2 square plus 5. 4 square is 3 square plus 7. And so what we get is a pattern which shows that n plus 1 square is nothing but n square plus 2n plus 1. So 3 square becomes 4 plus 5. 2 square becomes 1 plus 3. So you see what you're getting is the next square. All you have to do is you take the square of the existing number and add the next odd number to it, and that gives you the square of the next natural number. Cool. So 6 square is going to be 25 plus the next odd number, which is 11. 25 plus 11 is 36, and that is 6 square. And so on and so forth. Cool. There you go, guys. Hope this helped you. If you like this video, please share it and give it a thumbs up. Please subscribe to our channel if you haven't already. Thank you for watching. See you soon.